Good morning everyone, I'm Marie G. Mojados and the topic of my research paper is about waste management importance. Over the past few years, waste has been recognized as one of the major problems confronting government and city planners, thereby posing a serious threat to environmental quality and human health. Waste is all the unwanted useless materials, also known as garbage, trash, rubbish, refuse. If waste is not managed properly, it can cause serious problems to human health and the environment. It appears to be the most prominent problem in most cities and large towns around the world. This service is falling too short of the desired level of efficiency and satisfaction, resulting in problems of health, sanitation, and environmental degradation. Due to lack of serious efforts by city authorities, garbage and its management has become a tenacious problem. Moreover, unsafe disposal of garbage and wastewater coupled with poor hygiene is creating opportunities for transmission of disease. Solutions to problems of waste management are available. However, a general lack of awareness of the impact of unattended waste on people's health and lives and the widespread perception that the solutions are not affordable have made communities and local authorities apathetic towards the problems. Waste management refers collectively to the collection, transportation, handling, and disposal process of dealing with removal of waste around the world. Waste management involves the handling of waste materials from the time it is made to its disposal. Managing of waste reduces or eliminates adverse impact on the environment and human health and supports economic development and improved quality of life. A number of processes are involved in effectively managing waste for a municipality. Waste management generally covers all aspects of waste, including waste reduction. We should reduce waste at the source. It can be done if people minimize the waste they produce on daily basis. Historical background. Letter A. Early waste disposal. In ancient cities, waste were thrown onto unpaved streets and roadways, where they were left to accumulate. It was not until 320 BCE in Athens the first known law forbidding this practice was established. At the time, a system for waste removal began to evolve in Greece and in the Greek-dominated cities of the Eastern Mediterranean. In ancient Rome, property owners were responsible for cleaning the streets fronting their property, but organized waste collection was associated only with state-sponsored events such as parades. Disposal methods were very crude, involving open pits located just outside the city walls. As population increased, efforts were made to transport waste further out from the cities. Letter B. Development of waste disposal. A technological approach to solid waste management began to develop in the latter part of 19th century. Watertight garbage cans were first introduced in the United States. The sturdier vehicles were used to collect the transport waste. A significant development in solid waste treatment and disposal practices was marked by the construction of the first refuse incinerator in England in 1874. Technological advances continued during the first half of the 20th century, including the development of garbage grinders, compaction trucks, and pneumatic collection systems. By mid-century, however, it had become evident that open dumping and improper incineration of solid waste were causing problems of pollution and jeopardizing public health. As a result, sanitary landfills were developed to replace the practice of open dumping and to reduce the reliance of waste incineration. Two types of waste. Letter A. Generation and characteristics. A clear appreciation of quantities and characteristics of the waste being generated is a key component in the development of robust and cost-effective solid waste management strategies. Although amongst some of more developed countries within the region, the quantification and characterization of waste forms the basis for management and interventions. Elsewhere, little priority is given to the systematic surveying of waste arising and the quantities, characteristics, seasonal variations, and future trends of waste generations are poorly understood, although there is a lack of comprehensive or consistent information at the country level. Some broad trends and common elements are discernible. Municipal solid waste, or MSW, is generated from household, offices, hotels, shops, schools, and other institutions. The major components are food waste, paper, plastic, rugs, and metal, and glass, although demolition and construction debris are often included in collected waste, as are small quantities of hazardous waste, such as electric light bulbs, batteries, automotive parts, and discarded medicines and chemicals. Number 2. Industrial solid waste. Industrial solid waste is the Asian and Pacific region, as elsewhere, encompasses a wide range of materials of varying environmental toxicity. Typically, this range would include paper packaging materials, waste from food processing oils, solvents, resins, paint, and sludges, glass, ceramics, stones, metals, plastic, rubber, leather, wood, cloth, straws, and abrasive, and etc. Number 3. Agricultural waste and residues. Expanding agricultural production has naturally resulted in increased quantities of livestock, waste, agricultural crop residues, and agro-industrial byproducts. Number 4. Hazardous waste. With rapid development in agricultural, industry, commerce, hospital, and healthcare facilities, the Asian and Pacific region is consuming significant quantities of toxic chemicals and producing a large amount of hazardous waste. Currently, there are about 110,000 types of toxic chemicals commercially available. Each year, another 1,000 new chemicals are added to the market for industrial and other uses. Letter B. Environmental impacts of waste. The economic growth and urbanization experienced in many parts of Asian and Pacific region over the past 10 to 15 years has significantly escalated the quantities of MSW being generated in many cities, including Bangkok, Beijing, Mumbai, Calcutta, Colombo, Dhaka, Hanoi, Jakarta, Kuala Lumpur, Manila, and Shanghai. United Nations 1995, Co. and Aziz 1995. Uncontrolled open dumping in the peripheries of many of the region's cities has resulting in the degradation of valuable land resources and the creation of long-term environmental and human health problems. The events of July 2000 at the Quezon City garbage dump on the outskirts of Manila, where hundreds of people were killed by the collapse of a 7-story high open dump stand testament to the direct potential consequences of uncontrolled dumping. 2 waste management characteristics. Letter A. Composition and properties. The sources of solid waste include residential, commercial, industrial, institutional activities. Certain types of waste that cause immediate danger to exposed individuals or environments are classified as hazardous. All non-hazardous solid waste from a community that requires collection and transport to a processing or disposal site is called refuse or municipal solid waste, MSW. Refuse includes garbage and rubbish. Garbage is mostly decomposable food waste. Rubbish mostly dry materials such as glass, paper, cloth, or wood. Garbage is highly putrescible or decomposable, where is rubbish is not. Trash is rubbish that includes bulky items such as old refrigerators, couches, or large tree stumps. Letter B. Generation and storage. Rates of solid waste generation vary widely in the United States. For example, municipal refuse is generated at the average of approximately 2 kg or 4.5 pounds per person per day. Japan generates roughly half this amount. Yet in Canada, there is rate of 2.7 kg, almost 6 pounds per person per day. In some developing countries, the average rate can be lower than 0.5 kg or 1 pound per person per day. This data include refuse from commercial, institutional, and industrial as well as residential sources. The actual rates of refuse generation must be carefully determined when a community plans a solid waste management project. Waste management collection. Letter A. Collecting and transporting. Proper solid waste collection is important for the protection of public health, safety, and environmental quality. It is a labor-intensive activity accounting for approximately 3/4 of a total cost of solid waste management. Public employees are often assigned to the task, but sometimes it is more economical for private companies to do the work under contract to the municipality, or for private collectors to be paid by individual homeowners. A driver and one or two loaders serve each collection vehicle. There are typically trucks of the enclosed compacting type with capacities up to 30 cubic meters or 40 cubic yards. Letter D. Transfer station. Of the final destination of the refuse is not near the community in which it is generated, one or more transfer stations may be necessary. A transfer station is central facility where refuse from many collection vehicles is combined a larger truck or vehicle. Wall-top trailers are designed to carry about 76 cubic meters or 100 cubic yards of uncompacted waste to a regional processing or disposal location. Closed compactor type trailers are also available, but they must be equipped with ejector mechanisms. In a direct discharge type of station, several collection trucks empty directly into the transport vehicle. For waste treatment and disposal. Letter A. Incineration. Number 1. Furnace operation. Burning is very effective method of reducing the volume and weight of solid waste. It is a source of greenhouse gas emissions. In modern incinerations, the waste is burned inside properly and designed furnace under very carefully controlled conditions. Number 2. Energy recovery. The energy value of refuse can be as much as 1/3 that of coal, depending on the paper content and the heat given off during incineration. Can be recovered by the use of refractory lean furnace coupled to a boiler. Boilers convert the heat of combustion into steam or hot water, thus allowing the energy content of refuse to be recycled. Letter B. Number 1. Sorting and shredding. The composable materials in refuse are isolated from glass metals and other inorganic items through sorting and separating operations. These are carried out mechanically, using differences in such physical characteristics of the refuse as size, density, and magnetic properties. Number 2. Digesting and processing. Pulverized waste is ready for composting either by the open windrow method or in a enclosed mechanical facility. Windrows are low mounds of refuse. They are turned into mix every few days to provide air for the microbes digesting the organics. Depending on moisture condition, it may take 5 to 8 weeks for complete digestion of the waste because of the metabolic action of aerobic bacteria. Temperatures in an active compost pile reach about 65 Celsius or 150 Fahrenheit, killing pathogenic organisms that may be in the waste material. Letter C. Sanitary landfill. Number 1. Constructing the landfill. The basic element of a sanitary landfill is the refuse cell. This confined portion of the site in which refuse is spread and compacted in thin layers. Number 2. Controlling byproducts. Organic materials burned in a landfill decomposes by anaerobic microbial action. Complete decomposition usually takes more than 20 years. One of the byproducts of this decomposition is methane gas. Number 3. Importance in waste management. In communities where appropriate sites are available, sanitary landfills usually provide the most economical option for disposal of non-recyclable refuse. However, it is becoming increasingly difficult to find sites that offer adequate capacity, accessibility, and environmental conditions. Letter D, for the last one, recycling. Number 1, separation. Before any material can be recycled, it must be separated from the raw waste and sorted. Separation can be accomplished at the source of the waste or at central processing facility. Number 2, reuse. Recovered broken glass can be crushed and used in asphalt pavement. Color sorted glass is crushed and sold to glass manufacturer as cullet, an essential ingredient in glass making. Steel cans are baled and shipped to steel mills as scrap, and aluminum is baled or compacted for refuse by emelters. Aluminum is one of the smallest components of municipal solid waste, but it has the highest value of recyclable materials. Therefore, I conclude, waste causes pollution, contributes to climate change, and squanders more money, energy, and natural resources than most of us realize. Waste management is a critical issue that requires immediate government intervention. In our society, there is now relatively little awareness of this problem. The behavior of generating garbage is too dangerous, not only for today's generation, but also for future generations. Waste minimization or source reduction can provide a number of advantages, including reduced use of the resources and lower waste toxicity, or what we call waste disposal, the collection, processing, and recycling or deposition of waste materials of human society. So, the most important purpose for effective waste management, of course, is to protect the environment as well as health and safety. That's all. Thank you for listening.